So we're on day 2. Solving trig equations, that's what we're doing all units long. Yesterday was graphically, just the left bound, right bound, guess. Use the calculator to get an answer. Today we're going to, let's just go 2 Roman numerals. One without calculator and one with calculator. I guess a big difference today is that we're going to find all solutions, not just solutions between 0 and 2 pi. So we'll see how that looks in a minute. And that's kind of the key to today, is making sure we get all of them. You could never get all of them with just a calculator, right? I mean, you look at your window 0 to 2 pi, that'd get you some of them. I guess you could look 0 to 4 pi, that'd get you twice as many. 0 to 6 pi, that'd get you some more, but it keeps going forever, and so you can never get all of them with just a calculator. And so we got to add a little bit of something to what we did yesterday to get all of them. Well, we'll get there in a minute. So first is no calculator. And remember, we're going to split up the test days, no calculator one day and with calculator one day. So no calculator. Probably the easiest way to do these is just work an example, or work several examples. 3 sine x plus 5 equals 5 sine x plus 6. So any ideas on what we could do with that?
Make it equal 0.
Okay, so yesterday we made it equal 0. So we're not going to do that today, but we do want to move some things around. So I'm going to subtract 5 sine x over. In fact, we're going to treat this more like a normal equation where we get all our x stuff on one side and all the not x stuff on the other side. So negative 2 sine x equals 1. And then we want sine of x by itself. So if we divide by negative 2, sine of x equals negative 1/2. And, maybe I should have said this, because we don't have a calculator, all our answers are going to be unit circle values. All right, we're going to end up with an answer that we can get without a calculator. So it has to be from the unit circle. So let's see. I always do a little picture on these. Sine of x equals negative 1/2. So sine is negative in the down quadrants, because sine is the up and down coordinate. 1/2. Let's see. You might just remember that goes with over 6. Or you might be thinking the y-coordinate's 1/2, and that's the short side. So however you remember it, or figure it out. It's not straight memory. It's a lot of figuring out. Looks like there's 2 answers here. So what's this third quadrant answer? Yep, 7 pi over 6. And what's the fourth quadrant answer? Can't read your lips with the mask on. 11 pi over 6. Or negative pi over 6. You can do either one, and I'll show you why in a minute. But if you go the long way around, that's 11 pi over 6. But that's only 2 answers. If we graph this, I remember what the sine graph looks like. There's an infinite number of answers. The other answers come from spinning around more than once. So if we'll add 2 pi, that would get us another answer. And if we'd add 2 pi again, that would get us another answer. And if we add 2 pi again, that would get us another answer. So we're going to add 2 pi k, where k is an integer. So that basically means add 2 pi as many times as you like. Same thing with 11 pi over 6. Plus 2 pi k means you can add 2 pi or subtract 2 pi as many times as you like. By the way, on that second one, if we subtracted 2 pi, that would be negative pi over 6. And so if you saw that angle and you were thinking negative pi over 6, that's fine, because that's the same thing. Negative pi over 6 plus 2 pi k is the same thing as 11 pi over 6 plus 2 pi k. It's just a matter of which way you go to get there. And so I guess it's nicer than the restricted ones where you could only use the negative one. Now it doesn't matter because we want all the answers anyway. So combination of knowing the unit circle, knowing that it's 2 pi all the way around, or that the period for sine is 2 pi. Just putting a couple things together. Let's do one with tangent. Tangent of 2x equals negative root 3 over 3. Tangent of 2x equals negative root 3 over 3. Well, don't worry about the 2x just yet. Let's just think, where is the tangent negative root 3 over 3? Good, the tangent 3 trick, so something over 6, for sure. And if tangent's negative, that would be in the second and fourth quadrant. So that would be 5 pi over 6. But there's a trick to tangent that's a little bit different. Of course, tangent's always a little bit different. The period for tangent, what's the period for tangent? Do you remember? Pi. Because tangent answers are always pi apart, not 2 pi apart. So I only need to pick off one answer from the unit circle, and instead of adding 2 pi k, I'm going to add pi k. Because if I can land at one answer, if I go pi away, I'll be at the other answer. So tangent's a little bit tricky. I guess maybe it's easier because you only have to do one answer. But then it's plus pi k instead of 2 pi k. Now this 2x, this means that 2x has to equal 5 pi over 6 for our equation to work. Right? If this argument is 5 pi over 6, then we get our answer that we want. So that means that 2x has to equal this. But I don't really want to know what 2x is. I want to know what x is. So I need to divide everybody by 2 to get x by itself. And maybe multiplying by a half might be a better way to say that for the right-hand side. So x equals 5 pi over 12 plus k pi over 2. So when the argument isn't just x, there's that extra step at the end. And what's in parentheses isn't just x. You've got to be careful at the end of the problem. Let's do another one like that. Plus, let's do a cosine. 2 cosine x over 2 plus square root of 2 equals 0. Right, so I'm going to subtract the square root of 2 over and then divide by 2. Hopefully that's not too much algebra at one time there. Two steps at once. Subtract the square root of 2 and then divide by 2. So So the x over 2 is a little bit strange, but I can't fix that yet. Let's see, where is the cosine?
Is that negative square root of 2?
Yes. I subtracted square root of 2, and then I divided by 2. So what quadrants have a negative cosine? Two and 3. Yeah, 2 and 3. And the root 2 over 2, that's the one in the middle. So that would be 3 pi over 4 and 5 pi over 4 plus 2 pi k, because you can spin around as many times as you like. But now I need to get x by itself. So what should I do on this problem to get x by itself? So don't worry about the ugliness on the right-hand side. I've got x over 2, and I want x by itself. Let's multiply by 2. So multiply everybody by 2. I guess we can do it this way. So x equals, let's see, the 2 over 4 would reduce to 3 pi over 2. Everybody gets the 2, so plus 4 pi k. 5 pi over 2 plus 4 pi k. So sine and cosine, you end up with 2 sets of answers. Tangent, you only get 1 set of answers because the period is half as long. So you end up sort of the same number of answers. You just need 1 statement to write it rather than 2 statements for sine or cosine. Right, so you got to know the unit circle today. Like there's no way around that. Now we've done enough unit circle where I'm okay with that one. Let's move on to the no calculator, or excuse me, with calculator section. So these will not be on the unit circle. The trick with this is that the calculator gives 1 answer. You have to figure out what's the other angle. Like all of our equations before had 2 answers, and we just know the unit circle well enough to know where they are. If you're using the calculator, it can't give 2 answers. It can only give 1 answer. Your job, or the job today, is to find the other angle, because the calculator can't do that for you. The calculator is smart enough to give you 1 answer, but it can't give you both answers. Show you what I mean. Sine of x equals 0.465. Definitely not a unit circle value, right? Who knows what that is? So we can use the calculator and do inverse sine of 0.465, right, to undo the sine. So grab a calculator. Oop, there's one of our pretty graphs from yesterday. But we're not graphing today. We're going to do it differently today. We're just going to do inverse sine of 0.465, still in radians. And that gets me 0.484. Okay, Okay, let's draw this out and see if we can figure out what else is going on here. Sine is positive. So sine is positive in the first and second quadrant. So I have no idea what the angle looks like, but something like that, where this height is 0.484. No, the height is 0.465. The angle we just found was 0.484 from the calculator. Oops, 0.465. There we go. So I would really like to know what this other angle is. Well, the symmetry says that this angle is 0.484. That's not really how we measure angles, but it's 0.484, like that's the angle opening there. So can you figure out what this red angle is if this little piece is 0.484? Here's a hint. Halfway around is pi. So how can I figure out the opening, the red angle? Pi minus. So the other answer for sine, the other answer is pi minus whatever your first answer is. So pi minus, that's the key for inverse sine. That's how you find the other answer. So 0.484 plus 2 pi k, because we want all of them. And then it's easy in the calculator because that answer is sitting there, so you can just do pi minus answer. You don't have to type it all in, just pi minus answer. You know where the answer button is on the calculator? One of the greatest buttons they put on the calculator. Down there at the bottom. So if you get something that you need and you don't want to type in all the decimals again, you hit answer and it'll use the most recent answer that you got. So 2.658 plus 2 pi k. So I'll summarize these when we get to the end, but for sine, it's pi minus. So the calculator gives you one answer, pi minus the first answer gets you the other answer. Let's do a cosine problem. Cosine of x equals 0.263. Let's see. The first answer is really easy. I could just go to the calculator and do inverse cosine of 0.263. 1.305. But we've done enough problems to know that there's probably two answers. So let's do a quick sketch and see if we can think where the other answer is. Let's see. Cosine is positive in the where the left right is positive, so it's positive over on the right. So something in the first and something in the fourth. The calculator just told me that this opening was 1.305. Cosine's even easier than sine. If that's 1.305, what's my other angle? What's that? I mean, the opening is 1.305, but if I'm measuring down, then that angle is negative 1.305. So for cosine, a plus or minus will accomplish what you need. And again, the calculator can't help you with that. It's just you have to know that that's where the other answer is. So sine is pi minus, cosine is plus or minus. Tangent. So let's say tangent of x equals 2.41. So first answer would be inverse tangent of 2.41. I mean, you better get half the answers right on the test, right? Because that's as easy as it gets. Inverse tangent, 2.41, 1.177. All right, now let's think about where that other answer is. Let's see, tangent is positive in the first and third quadrants. So I have no idea where this angle is. So I'll just put it there. So there's our 1.177 that the calculator told us. So how do I get from 1.177 to the other angle? How much of a rotation is it? Yeah, I need to go pi more. So, but pi is the period of tangent, and so if I just do plus pi k, that will catch all of the answers. So it doesn't even require two statements, because plus pi k will catch all of the answers anyway. So tangent is the easiest of all, as long as you remember the period is pi rather than 2 pi for tangent, then plus pi k gets you all the answers. Let me see if I can summarize. We've already said all of this. For sine problems, x is equal to inverse sine of whatever plus 2 pi k. In fact, we'll say that's x1. That's the first answer that the calculator gives you. The second answer is pi minus x1 plus 2 pi k. Again, if you need the picture can help you kind of think through and where that comes from. For cosine, our answers are plus or minus inverse cosine of whatever plus 2 pi k. So that one's pretty easy too. Just don't forget the plus or minus. And then lastly, for tangent, well, inverse tangent of whatever. And then plus pi k will handle all of the answers. So that's the new stuff for today. How do you get the other answer out of the calculator? Because the calculator doesn't know the other answer. It gives you one answer. You have to know how to get the other one. So for sine, it's pi minus whatever you got. For cosine, plus or minus will get it. And for tangent, just the plus pi k will get the other answer. All right, let's do a few together to make sure we're okay with this. So we're on worksheet 2. So let's look at, why don't you try number 2 first. That should be a straightforward one. We'll just see if you remember what's going on. So try number 2 and then we'll go over that one. So there's two options for describing that angle. You can go the positive route and say it's 2 pi over 3, or you can go the negative route and say it's negative pi over 3. That's the same set of answers. You need one of them. You don't need both of them. There's a lot of other ways. I suppose you could really get creative and say it's also a long way around. That'd be, what, 5 pi over 3 plus k pi. So There's lots of ways to describe it. Probably you wouldn't pick 5 pi over 3. You'd probably pick this one or this one. But it wouldn't be wrong if you said 5 pi over 3. All right, let's skip down to number 10. What will we do first on number 10? What do you want to do first on number 10? Jenna, what do you want to do first on number 10? Good, let's divide by 2. So cosine of x over 2 equals root 2 over 2. So my mind is now thinking, where is the cosine equal to root 2 over 2? Because that's what x over 2 will be. So I'm going to stop there, and you see if you can finish it out from there. Where is the cosine equal to root 2 over 2? And then there's an extra step after that. So here's your answer to number 10. Cosine is root 2 over 2 at pi over 4 and negative pi over 4. That's the plus or minus. But that's what x over 2 should be. Then we multiply by 2 to get x by itself. Let's look at number 16. So we're into the calculator section. I guess we should have read the directions. Find all solutions of each equation using a calculator. Round answer to 3 decimal places. So looking at number 16, what do you want to do first on 16? Divide by 5. So cosine of 3x equals negative 3/5. So how do I get my first answer? 3x will equal what? Again, I got a calculator, so how do I figure out, how do I make the calculator give me my answer? Well, you guys you're all typing something in, so I assume that's what you're typing in. Inverse cosine of negative 3/5. Second cosine, negative 3/5, is 2.214. So that's one answer for what 3x is. So we're still a couple steps away. So what else do I need to add to this, to include in this answer before I divide by 3? There's 2 more things that need to be a part of this answer. Plus or minus, that'll get me the, and then plus 2k pi, or 2 pi k. The order doesn't matter, so sometimes, I try to say it the same way every time, but sometimes I'll say it in a different order. But you can put them in any order you want. k2 pi, k pi 2, however many different ways you can say that. Andrew? Yes, I'm not done yet. So you're right, I do need to divide it by 3 because I want to get what x is. So it's just a little bit weird because you go to the calculator before you're really done with the problem. And so you get a calculator answer, but that's not really your final answer because now we need to divide by 3. And if we haven't messed with our calculator, that number is still sitting there, so just divide by 3. 0.738. Plus or minus is still there. Don't forget to divide everything by 3. It's a kind of a common mistake. Is remember, divide that by 3, but then to leave the 2 pi k. But you got to divide that by 3 as well. Or I think maybe the problem is people don't put the 2 pi k on at the beginning. They wait till the very end and put it on, but by then it's not quite accurate anymore. All right, let's do one more. Let's try number 18. So why don't you try 18 on your own, start to finish. Got lots of stuff going on in 18. A little bit of algebra, then the calculator, and then how do you find the missing angle, At least it's just x and not 2x or x over 2. So try 18 and then we'll go over that one. So here's all the easy steps. Inverse sine gets me my first answer. But my second answer I get by doing pi minus the first answer. 2.757 plus 2 pi k. So that one wasn't too bad, but again, you've got to know, the calculator is great, but it only gives you one of the answers. You've got to know how to get the other answer. That's kind of the whole point of today is, well, what's the other answer? All right, we went longer than usual today, but that's okay, especially since I won't see you guys for a couple of days. So try the rest of them. I will post odd answers. Actually, I think they're already posted, so you can check some of your answers. You'll note that we did some even ones, so most of the answers are available to you.